So just with what we have, we can already start to analyze and solve a lot of situations. What do we have? Right now, we have the fact that momentum is mass times velocity. And we have change in momentum. What's another word for change in momentum? Impulse. That is mv final minus mv initial. There's my final minus initial. And it's also force times time. Okay? What can we do with that? Well, we can start to analyze, well, let's see. A force of 8 newtons acts on an object for 10 seconds. The mass of the object is 4 kilograms. Okay. James, what does part A want me to find? Keep reading. Magnitude just means size or answer. Almost. Change in momentum. It wants me to find, what's another word for change in momentum? It wants me to find impulse. So the first thing I'm going to do is I'm going to say, okay, it wants me to find that. There's 2 ways to find impulse. I can either find the impulse by going force times time, or I can find it by going final minus initial. Read the question. James, did they give me a final and an initial velocity, or did they give me a force and a time? Force and a time? Okay. Oh, you know what? Let's write the equation first because we're still learning this. It's going to be force times time. James, how big is the force? Yep. How big is the time? In your head, what's 80 times 10? Well, sorry, what's 8 times 10? 80 times 10 is 800. 8 times 10 is 80. Freudian slip, you say one thing. Units. Momentum. Kilogram, meters per second. Mass times velocity. James, what's B want me to find? What's another word for impulse, or another phrase for impulse? Change of momentum. You know what? I think it's the same answer. And it is. Those 2 terms, impulse and change in momentum, are interchangeable. I want you to realize that, because every year on the test, I ask a kid to find the impulse, and they leave it blank or they freeze it. No, it's change in momentum, and change in anything is final minus initial. James, what's C want me to find? You know what? Impulse is also equal to m change in velocity. That was another way to write this. Yeah? James, how could I get the change in velocity, the delta V, by itself? Yep. Oh, thank God you guys are getting good at formula manipulation, because to try and do each one of these as a separate equation would drive me crazy. So if I hear you correctly, you're telling me the change in velocity is going to be the impulse divided by the mass. James, what was the impulse or the change in momentum? Yep. And I told you the mass, what was it? 4? Hey, James, you can probably do this one in your head too. 80 divided by 4? You probably don't. When you see the answer, you'll go, could you really have done that in your head, I think, James? Yes. 20? 20 what? Well, it's velocity, so meters per second. What this is saying, Mason, is your velocity changed by that much. If you were originally going 2 meters per second, now you're going 22 meters per second. If you're originally going 8 meters per second, now you're going 28 meters per second. Oh, if you were originally going negative 4 meters per second, now you're going positive 16 meters per second. Or, if your final velocity was 12 meters per second north, what was your initial velocity? Prove it. You're right, but you know what? I know that I just found that. Yes? What's change in anything? Yes? What is this question wanting me to find? Oh, That touch screen is still on. Ay, ay, ay. What's right in front of the VI, Rob? I don't like that negative. Oh, we've done this dance before, haven't we? I'm going to plus this there. At the same time, I'm going to minus that there. Jaden, we've done that a bunch of times before. I think we're going to get this. VI equals VF takeaway delta V. By the way, Rob is right. It is 8 meters per second south. But here's a lovely little, we can prove it, especially if it's yuckier numbers. What was V final, James? Yep. No, V final from part D. It says, don't overcomplicate it. 12 minus. What was the change in velocity from part C, James, my friend? Yes. And I get negative 8. Now, what does negative 8 mean? Now we got to put direction into context. What direction was the 12? And we let that be positive, so what direction would a negative be? There you go. VI was 8 meters per second south. And if you can, Cam, just kind of see that as your answer, you do not have to walk through all this. But in our notes, Derek, I walked through this. So if it's yuckier numbers or you can't see it, you know what? We can still use our standard tricks of the trade. Example 2. A snow scooter has a mass of 350 kilograms. A constant force acts on it for 60 seconds. The snow scooter's initial velocity is 2.5 meters per second, and its final velocity is 18 meters per second. Eugene, what's A want me to find? What's another word for change in momentum? Both of those tell me I start out doing that. Equals. There's 2 ways to find impulse, Eugene, my friend. There is the force times time way. There is the final minus initial, V final minus initial way. Read the question. Did they give you a force and a time, or did they give you a final and an initial velocity? Okay, this is the kind of Mason mental checklist you're going to do whenever you're finding impulse. Am I going to use force time, or am I going to use V final minus V initial time? So this is going to be M V final minus M V initial. Or some of you might like to write it V final minus V initial. Those 2 equations are the same thing. I tend to dislike brackets, so I usually just write it out. Eugene, what's the mass? What's V final? Minus, what's the mass? Again. What's V initial? We pause. Was there a change in direction? Did it suggest that there's like a north and a south or anything like that? Say no. Okay, if there was, I would let one of these be positive, one of these be negative. I usually let initial be negative, so I get a minus minus, which is a plus. But here it looks like it's all in the same direction. All right, now I need my calculator. Or do I? 18 minus 2.5 is going to be 15.5. Yeah, I'm going to use a calculator. $350 times 18 minus 350 times 2.5. What change in momentum, what impulse did this snow scooter undergo? 5,425. 5,425 what? Hey Eugene, what's part B want me to find? What did I find in part A? You know what would be cool if there was a version of impulse that also had force in it. This one. You see how we're almost doing circles here. We're almost coming back to where we started. But what I'm saying is we can really, with a bit of cleverness, use that 3-in-1 equation to get to a lot of stuff here. How would I get the force by itself? By the way, did they give me a time in the question? Look down and read for yourself. Or it's up there, I guess. Did they give me a time in the question? Ah, now I know why they did that. Okay? So force is as well. What was the impulse? 5,425. What was the time? 60. 1 minute. And I get 90.4 newtons. Not a very big force. Before you go to the next page, looking at example 1A that James and I did, I've told you there's two ways to measure momentum or impulse. One way is kilogram meters per second. Can you see why in number 1, if I wasn't paying attention or if I was just writing fast, I could also go Newton seconds? Because we went force times time. And I think I told you guys last day I flip-flop between the two units. Boyana, usually if I've used this, I'll instinctively write my answer like that. Usually if I've used this one with velocities, I'll write my answer as kilogram meters per second. I'll take either though, Luke. I'm fine with either. Okay. Next page. Rockets. Rockets are great examples of momentum. A rocket of mass that, starting from rest, is acted upon by a net force of that for 120 seconds. What's the final velocity of the rocket? What's this question want me to find? VF. So let's put it all together. Did they give me a VI? Yeah. Did they give me a force? Yep. Did they give me a time? Okay. So remember, here was the equation in the box that I gave you last day. I told you that this was equal to this was equal to that. I'm going to start out like this. By the way, did this question ask for or mention impulse? That's why I didn't write delta P right away. I went to this one. This, Mason, you okay with that? Or did I lose you?
Yeah, I'm good with that.
Yeah? Right? This is all from that big box in lesson 1 that 3-in-1 equation that I went on that rant about. Right? This is the third version. This is the same as m v final minus m v initial, because that's what change in means. Final minus initial. I'll put the vector signs on there to remind myself to pay attention to directions, but since I don't see a north or a south, I'm going to relax a bit. Mason, what did you say this question wanted me to find?
Yeah.
That guy, right there. How would I get the VF by itself? Well, the first thing I think I would do is move this thing over, because it doesn't have a VF. How would I move the... Okay, so if I hear you correctly, we'll do this one in steps. Some of you may get good enough in your homework to do it in your head again, and I think that's great. The force delta T would drop down. You're telling me I'm going to go plus m VI. That equals m VF. How would I get the VF by itself? There, yet another equation that I'm not going to write down or memorize, or I can figure it out. Is that okay? Yeah. Let's see if we got all this. Apparently the final velocity is going to be the force. Did they tell me the force? Yep. 2.3 times 10 to the 4th. Time, 120. Plus the mass, 2.6 times 10 to the 4th. VI. Oh, you know what? VI is 0. You know what I could have done if I was really paying attention, Kareem? I could have just crossed that out and ignored it. But just in case, if there had been a VI that wasn't 0, it would go there. But since it's 0 now, I'm just going to ignore it. Divided by the mass. 2.6 times 10 to the 4th. Okay. Probably some brackets and scientific notation and stuff here. Let's see. Bracket 2.3 times 10 to the 4th times 120 divided by 2.6 times 10 to the 4th. 106 meters per second, I hope. Okay. So far, so good, Hannah? Good yawn? Okay. All I'm showing you for the next few minutes is clever ways that we can use the concept of impulse, change in momentum, and that it's a force times time, and that it's a mv final minus mv initial. Hannah, example 4, what do they want me to find? Example 4? Yes? You're way overcomplicating that. Okay? We could find this by doing a free body diagram, by going winner minus loser. But the nice thing about the impulse equation, it gives us a lovely shortcut. Because I do notice, did they give me a mass? Did they give me a V initial? Did they give me a V final? Stop. Yes? Did they give me a time? Then I can jump straight to this. Force delta T equals m V final minus m V initial. Okay? Are any of these 0? What? Final? So let's go like this. Hannah, how would I get the, you said force, yes? How would I get the F by itself? Yeah. I'm going to argue that's quicker than get the obvious. What are the winner? It's quicker. It only works for nice, clean questions. In other words, for more than one mass and many different forces, it's not effective. But if all I want is the one single unbalanced force, the braking force, this will work just fine. I can go, apparently the force is going to be negative mvi over t. Over delta t, but I stopped writing this delta. Hannah, what was the negative? What was the mass? And VI was 32, and the time was 1.6. Negative 32,000? Don't all rush for your calculators at once, boys and girls. Is it negative 32,000? Yeah, I can do it in my head. The 1.6 and the 16 cancel quite nicely. Negative 32,000, and it's a force, newtons. What's the negative telling me? If the car was going north, which way must the force act? South. If the car was going west, which way? You know what? The force has to act backwards because that's how you brake. A rock falls from a high building and it strikes the ground below. What is the force, magnitude, and direction if it comes to a stop in 0.350 seconds? How hard does the ground hit the rock? Okay. Cool. Sam, what's this question asking me to find?
Force.
Force. Is there a time?
Yes.
Let's try solving this using this equation here. Force change in time equals mv final minus mv initial. Okay. I think my initial velocity is 0. My final isn't. My final is 0 after I hit the ground, but not when I hit the ground. Do I know v final?
No.
We need... Sam, what haven't I used yet? What else did they tell me?
How high the building would drop?
Ah! D equals...
40 meters?
Nope.
-40?
What?
-40?
Are we ending up below from where we started? And I told you we have to now again be careful with our vectors and our direction. Oh, I know A while in free fall, don't I? Negative 0.8. VI was 0. I'm looking for an equation that has VF, AD, and VI in it. There is one.
VF squared equals VI squared plus 2AD.
Hey, this is great review. Although conveniently VI is 0. Oh, this is VF squared. How do I get rid of a squared?
Take the square root.
Coming back to you, Cam? Remember all this from before Christmas? You were totally zoned out? Mm-hmm. It's going to be 2, negative 9.8, negative 40. 2 times negative 9.8 times negative 40, square root. Oh, that's lovely. Holy smokes, worked out evenly. It's going to hit the ground at 28 meters per second. Although, when it hits the ground, which way is it traveling? So you could call that negative if you wanted to. You could leave it positive, and that just means if you get a positive answer, that force is down. If you get a negative answer, the force is up. Okay. Let's call it negative. How would I get the F by itself over here?
You divide C.
Okay. It's going to be 2.5. Negative 28 all over 0.35. Oh, geez. Answer's working out flukily nice. Negative 200 newtons. So we have to do a little bit of thinking here. I said, what is the force, magnitude, and direction? So the force has a magnitude of 200 newtons. We have to interpret this negative. This negative is actually sort of a double negative. Well, which way does the ground apply a force when it brings you to a stop? Yeah, this is up. We let down, this is kind of a, we let down be negative, and then a negative negative would be an up. Or you can just clue in when you hit the ground, it does push you up. Okay. Couple more. And what do we got? Yeah, we'll finish. Good. Lots of time. Example 6. I'm assuming all of you, at least once in your life, have thrown a ball against a wall and then it bounced back towards you. maybe for longer than that. So here's the physics of that. A 4.2 kilogram ball, it's a heavy ball, moving at 4.65 meters second east hits a wall. The wall exerts a force to the west. Find the final velocity, magnitude, and direction of the ball. Is this question asking me to find the impulse? Brett, is this question asking me to find the impulse? No. No. But I can use impulse. What is this question asking me to find? Did it also give me a force? You know what? I'm going to start out by going force times time equals mv final minus mv initial. Impulse equals impulse. One way of finding change in momentum equals another way of finding changing momentum, but I think I can use this to find what's missing. Brett, are there directions in this question? Is there a change in direction in this question? So we're going to let one way be positive and one way be negative. What do you want to let be positive? What do you want to let be negative? Pick. Sorry? East positive. So put a little positive, put a plus sign there, put a negative in front of the newtons and a negative there because apparently the force is negative to the west. I would have let west be positive, but this will work no matter what. Brett, what does this question want me to find? How would I get VF by itself? Add it, divide it, what and what? By the way, I'm going to tell you, this is going to involve two steps. There's something I would do first before I tried to get the VF by itself. I would deal with, how would I move that? The whole thing. Why? Because there's a minus sign in front of it? In other words, my next thought would be F delta T plus MV I equals MVF. Is that okay? By the way, what if I was trying to get the VI by itself? What's right in front of the MVI? We've done this dance before. I would plus it to that side and at the same time minus the FT to that side. Okay. Oh, that trick still works. Keep going. We want the VF by itself. Yep. Can I just go like that and save myself rewriting it? Can you just, yes, you can, as far as I'm concerned. Okay. Plug and chug, here we go. You know what, let's do it up here. V final is going to be F. What's the force? Why is 350 wrong based on what Brett decided? Negative. You decided to make it negative, right? And that's why I wrote that, put it in front, right? Make it obvious. So negative 350. What's the time? 9:20. No, how much time in this question? 0.075. Pretty quick impact. Plus, what's the mass? 4.2. What's VI? And be careful with your signs, or double check to make sure you have the right sign, positive or negative. What's VI? All over, what did you say the mass was? 4.2. Now, if I get a positive answer, what direction will that be based on what you've decided? If I get a negative answer, what direction will that be based on what you've decided? Okay, good, crunch them. Is this a fraction? Yeah, is there more than one thing on the top? Yeah, brackets. Is there more than one thing on the bottom? No, you don't need brackets around the bottom. Is that right? Do you get, oh, geez. I must have stolen these from someone on the internet because I don't like to make stuff work out evenly. I'm too lazy. Do you get negative 1.6? Yeah? I'll write negative 1.6 meters per second, and then I'll put an equal sign, and I'll say 1.6 meters per second direction. West. Because it did say find the final velocity, and then in brackets it said magnitude and direction. Right? James, magnitude means size. Boy, I didn't leave much room for example 7. I think we can do this. Part A, part B if we write small. Braden, what's A want me to find? Another word for which is? No, it's not moment. I gotta be fussy. Impulse is not momentum. I've always added a couple of words in front of that. Impulse is change in momentum, which, in other words, that's why an object at a constant speed, although it has momentum, has no impulse, right? Change in momentum. So I'm going to start out writing impulse, change in momentum. There's two ways to find impulse. Read the question, Braden. Am I going to use the one with velocities, or I'm going to use the one with the force? How do I know? Not just that they gave me two velocities, but what does part B ask me to find? I'll bet you once I find the impulse, I'll probably use that to find the force. Okay. It's going to be mv final minus mv initial. What's the mass of this bullet? Braden, my friend, and be careful, it's not 12. So what is that in kilograms? Don't tell me the bullet's 12 kilograms. That's a cannon. How do I go from grams to kilograms? It's divided by 1,000. So I think 0.012 times 250. Oh, Braden, look up. Why can I do that? Yeah, rest. Okay. Yay. 0.012 times 250. 3 kilogram meters per second. Braden, what's B want me to find? What did I find in part A? What did I find in part A? I'm looking for one word. Huh? It'd be cool if there was an equation that had force and impulse in it. Is there? Oh, so if I hear you, you're telling me I can go force times time also equals impulse? How would I get the force by itself? Okay. Yeah? What's the time? 9:25. No, what's the... Oh. Did they give me the time in this question? Well, touch screen, things move around like crazy. Okay. So, what haven't I used yet that they gave me? I think, Sam, the distance here is positive because we're moving forwards. Yes? I know VF is 250. VI is 0. Is there a way I can use that to find time? Mm-hmm. There is an equation that has VF, VI, D, and T in it. T equals VD. Does that work? We have this one here, don't we? D equals 1/2 bracket VF plus VI times T. Don't we have that one?
Yeah.
Where VI in this case is a lovely 0. And I apologize, I'm having to write really, really small because I foolishly didn't leave you guys enough room. How would I get the T by itself? Braden, I think what I would do is I would divide by 1, or do I care about dividing by 1? Is that going to change anything? No. What would that 2's on the bottom side? Times by 2? Yes? And divide by VF. I'm having to really cram this in here. I think time is going to be 2 times D divided by VF. Yeah? It's going to be 2 times 0.85 divided by 250. That seems about right. Bullets go pretty fast. I imagine, James, it would leave the gun pretty fast. 0.068? Sorry, 0.0068? So what you get? And now we can plug that in way over here. Seconds? Time? What was the impulse, Braden?
3.
What was the time?
0.0068.
It's going to be 3 divided by answer button. The force is about 441 newtons. About 441 newtons. Am I going to get through the rest of this in this block, Mr. Dewick? It's going to be close, but not quite. So we're going to go like this. I'm going to pause here. Your homework so far is the stuff from lesson 1. But you are capable, if you want to get a head start, and you got 20 minutes, you might. Lesson 1 took most of my students about 15 minutes to finish, so if you want to get a head start, I think you can try number 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10, and 11. 12 is good. 13. I'm eventually going to assign pretty much all of these, but if you want to get a head start for now, you can. However, video to show you. Put your pencils down, look up.